Right, good evening everybody. My name's Paul Oliver. I have a company in Taranaki called IoT Taranaki. And first of all, can I have a show of hands of people who understand the term IoT or Internet of Things? Okay, as suspected. So what I'm going to do, the first part of this, is I'm just going to take you through a very quick introduction to what the Internet of Things actually is, and then we'll start getting into a couple of other use cases that we are involved with and using IoT. First off though, a bit of a thanks to the Taranaki Regional Council, a company up in Auckland called IoT Ventures. They make nodes and things. After the presentation, there's a table full of them over there that you can go and have a look at. EcoNode is playing a major part in the Predator Free 2050 program. They are supplying the little electronic boxes that go into the traps. And Primo Wireless, we're actually in partnership with these guys, and we put our gateways, which I'll explain, up to where it's supposed to go. So, quick intro to the Internet of Things. Basically, it describes a network that's set up, and the things on the network can then talk to the internet. So, you know, once that information is on the internet, it can be saved, put into data sets, and you can start making some intelligent decisions around what that data set or data sets is showing you. So in the context of the environment, this allows you to actually listen to the environment. So, you know, depending upon what your sensor is, you'll be able to understand what's going on out in the environment. And because of the technology that's being used, you can actually talk back to you can talk to the environment. So using this technology, you can send a command and it'll actuate something, you know, like turn a light on or close a gate or, you know, turn a motor on that does something. So using both of those, or all of those first three things, we can then start making some informed decisions about what's going on in the environment and to protect it and restore its muri. So, is this, no, okay. So basically, oh yeah, it does work. No, it doesn't work. Okay, so look at the little red dot down underneath there. The line of boxes above it is what are called nodes. They transmit information to these bigger blue boxes called gateways, and then from the gateways it heads off into the internet via our big blue box, which is a server, and then the other blue boxes on the right, they would be a computer that you guys might be looking at or an organisation might be looking at. That's how it works. And down the bottom, if you've got any security concerns, which is a pretty big concern amongst the IoT community at the moment, natively it's all encrypted, so it's not a problem. So this is the current coverage that IoT Taranaki has in the region. Each one of those circles is 10 kilometres in radius. And the impetus behind setting up this coverage has actually initially come from the Predator Free 2050 program. So you'll notice a little bit later on, I'll show you a map of what that program has, you know, at the rollout stage it's at, and you'll see that the coverage is sort of following that. There's actually about 30 gateways up there now around Taranaki, and we're going to be carrying on. Our goal is actually to give 100% or as close as practical geographical coverage to the region. So this is an asset which everybody in the region can use. Unlike the telcos, we won't get into that. No. Okay, so the gateways, those square white boxes, They can go up on top of, the one on the right here is actually an old milking shed at the top of, or in the middle of Waria Road, and the one on the left is a Primo site up the top of Palmer Road. The idea is to get them up as high as you can with the antenna sticking up the top to maximise your ability to receive. So you can read through that. It'll take me a while to go through it, but some of the added benefits to the environment by using IoT technology is, for instance, monitoring and optimising energy use in homes, buildings, factories and cities. And you may ask yourself, how does that save the environment? Well, basically, if you reduce the amount of energy that is required to run whatever you're doing, you also reduce the necessity for power stations that might not be economically, may not be environmentally particularly friendly to run. So you lessen the need for that. Air quality monitoring and analysis, for instance. You know, the word environment generally brings up visions of, you know, the land and whatever is around you, but it also applies on a personal level. For air quality monitoring, and for instance, okay, want to get rid of air pollution, but on a personal level, if you're sitting in a room like this, let's say, or maybe even a classroom, and you can monitor the CO2 levels in the room, for instance, that will tell you, obviously, what the CO2 levels are, but that actually has an effect on people's ability to listen and learn. So, you know, you could stick a CO2 sensor in a classroom, the teacher sees the CO2 levels are going too high, oh, maybe I should back off a little bit. Water quality monitoring and analysis, that's actually what started me off in this whole process. The advantages to doing that are, you know, pretty obvious to everybody, and I will go into a little bit of detail later on that. And tracking animal movements, that's been touched on more than once tonight. We're also involved with that. And a few other bits and pieces down the bottom, so I'll move on. So, this is the Predator-Free 2050 started a few years ago, and this is, as I mentioned earlier, the reason why we've started to roll this network out around Taranaki. It's been pretty successful. I'm not going to stand here and read this out, but you'll get a pretty good idea of the stages that the Predator-Free 2050 has been going through. They're up to, well, they will be, as summarised down the bottom here, up to stage 4 this year. And stage 1, 2 and 3 have obviously occurred over the last 3 or 4 years. The object of this exercise is to not only trap animals, but also to engender a sense of involvement by anybody involved. And to do that, one of the methods is to give a graphical representation of the traps that are on your land and at what state they're in. You know, on a large scale, that would save, let's say, a council putting a crew into a truck, heading off to wherever, walking around for the best part of a day checking traps. If they don't have to do that, that's, you know, going to save them a lot of time and money and effort. But on an individual level, again, it's the same applies. If you've got a farm with multiple traps on it, you may be a very busy farmer, which most of them are. You may not necessarily want to go and check those every week or whatever you feel as though it should be checked. So to do that, These traps here, you've obviously seen a picture of this one. It's for the Aroa school. It's the same trap, well, it's the same type of trap, but instead of the lure, we've actually got that little green box in the top right-hand corner there is a what's called a LoRa node. It will tell you whether or not the trap is sprung or set, and also it has what's called a heartbeat, which will tell our network that it's still alive, basically. Every 2 hours it'll say, hey, here I am, and we can go from there. So on the left-hand side, you can see this is what the the Taranaki Regional Council intend to do for the 2050 rollout. The areas in yellow are what have been done so far, and the areas in green with the numbers on it, they represent the years that the project is going to carry on around the mountain and in our region in general. What I forgot to mention about the network, and Victor made reference to it, is these boxes are battery operated. The batteries in these things, if they're designed properly, will last between 5 and 10 years. So you're not having to change batteries out on a regular basis. They transmit over a long distance. So the advertised distance in an urban environment, for instance, is about 2 to 3 kilometres. That's effectively through walls and buildings, even into car parks, and in some instances, stuff that's buried. Line of sight, however, these will do up to, advertised again, about 20 kilometres. So that's why we've got these gateways around the mountain picking up these traps. Those traps, there is currently about 3,000 of them out there, all of them with one of those nodes on it, transmitting in. We faced a few challenges, one of them being in particular the lahas around the other side of the mountain. If you've been around there, you'll notice that they're like pimples all over the ground, and it can prove quite difficult to, pick up radio signals if something's sitting down in a valley. And unfortunately, predators don't live on ridges and move around on ridges all the time. So that's one of the challenges we've had, and we're looking at ways and means of addressing that through either more gateways. Actually, we were thinking about tethered drones, even a thing called an aerostat, which is a helium balloon with a wing on it, which basically will sit in one place, and we'd stick a gateway on it and try out that. Haven't got that far yet, unfortunately. It costs about $800 to fill up a balloon of a decent size with helium, so we'll just wait on that one a little bit. Right, so we were mentioning one of the uses is for tracking, and where are you? As you mentioned, Landcare is starting to look at using what are called Nano trackers for monitoring muscular movement. The interesting thing is, if the picture on the left, that's a proof of concept unit, which in the spirit of collaboration came to us via Moscow and Amsterdam, and that's been getting tested by one of the guys at the Regional Council over the last month or so. It will communicate via the LoRa network, which is our network. LoRa stands for long range, by the way, and also has a GPS chip on it, so it will pick up the GPS coordinates of whatever animal it's on. And because these study periods can be of a limited duration, the battery that's attached to it to run it can be sized to, run basically for the study period, and then away it goes. On the right-hand side is one of the proposals for the actual mounting, mounting on the animal itself. You may or may not be able to see it, but that's actually a 3D printed to house the unit itself and the battery. The measurement you see, or the tape measure you see inside there, comes out to about 5 inches. So, some work has been done on shrinking that, making it more usable, and also making sure that there's certain ethical standards around putting things on animals which have to be adhered to. Basically around body weight versus the weight of the device that you're putting on to the animal, and that includes the collar and the straps. So that's all been worked on by Landcare, and assuming it's successful, apparently there is not a single data set on the planet that gives really good information on stoat movements and ranging. And if that is achievable through using this technology, that's going to be a first. A few people quite excited about the possibilities with this, actually. Okay, move on to my favourite subject, water. In case you didn't know, you have 100% water. 97% of it's actually taken up by salt water, which is not immediately usable by you. 2% of the remainder is ice, and then that leaves us with 1%. Down the bottom here, you'll see that of that 1%, 70% of it is actually used by agriculture. And of that 70%, roughly 60% is actually wasted because it's not actually going to where it needs to be, or too much water has been put on something that doesn't need it. And similar figures down the bottom for the other 30%. So you can see water is actually getting significantly wasted, and that 1%, that's it, that's all we've got. So we've got to look after it. So one of the ways of looking after it, there's a company over in Christchurch called Riverwatch. They make this wonderful device that you see this girl holding. It's called they call it their locker, and it's made out of recycled plastic milk bottles. Basically, it sits in the river, a stream, whatever water body you want to monitor, and will bring in information which will then be transmitted via a network very similar to ours to where it's needed. I actually had a chat with them yesterday, and one of my things is, actually it's on a lot of people's minds, is nitrate levels in water. Does it, I asked them directly, does it have a nitrate sensor on it? And actually nitrate sensors that will last a while are actually very expensive. One of the council guys proudly took me to the back seat of his ute and pulled out his cardboard box and said, "Want to look like cheap nitrate sensor?" Pulls this thing out, it's about that long, steel tube about that round, $16,000. That's a cheap nitrate sensor. So if you can get an idea of the nitrate, what's in the nitrate levels in the water, but not necessarily have it at a scientific grade level, and you can get trend data from it, it makes a lot more sense, because then you can put a whole lot of sensors out there relatively cheaply, start getting trends, and start seeing where problems are actually starting to develop. The sensors that are on this do not measure nitrate correctly, but nitrate concentrations can be inferred from a combination of some of the stuff that they've got on this machine. And again, all the information comes back via an IoT network. I I mean, it doesn't have to be LoRa, which is what we use. It can be a cellular network, it can be an NB-IoT network, anything that will get the information back where it's needed. Everybody read that? Good. And might be a little bit of a contentious issue here, but again on water, why, the council, the district council has recently voted to introduce water metering. The immediate reaction is probably, well, it can vary, I don't want to pay for water, it should be free, all that sort of stuff. But actually, apart from that, it has a lot of very good uses for the council, for the people that process the water, put the water out, pump it out, get it to your houses. Similar numbers to that agricultural one are coming out. Like 60% of it's getting wasted because it leaks whatever in the systems. IoT technology can put in sensors and things which will actually tell you where the leaks are. It'll tell you how well the system's operating. And save the water and obviously the council's money, budget, or whatever you want to call it. So just a couple of final comments. The network we've got in place currently is a little bit of an underutilised community asset. If you have any clever ideas about how to use IoT, come have a talk to me. I'll give you my contact details. There are many other use cases for IoT other than the environment. It's actually pretty much limited by the imagination. So you can have a think on that. And because it's outside it's only limited by your imagination, it requires you to think outside the square a little bit. One of the examples that I have, I like to relate, is a temperature sensor. You can have a temperature sensor set up in a room, and you may have a display sitting on the wall showing you the temperature. That's fine, so you'll know what the temperature in the room is, but what else can you do with it? So you save it somewhere to a data set, and then you have a look at it, and you suddenly realise it's going up and down during the day, 2 or 3 times. And then what's causing that? The sun only goes past the windows once a day, so it can't be that, it's got to be something else. And then light bulb goes on, you suddenly realise that the air conditioner is actually turning on and off. So by putting a temperature sensor in a room, you can infer something completely different to what it was supposed to be measuring or telling you. So use that thought process, in your ponderings if you feel interested. And education for IoT. IoT itself is going to actually radically change things around the place. And we need to start getting folks like yourself, you're already into it, and it's marvellous to hear what you guys are doing. We need more of it. We need more teachers that are telling the kids about IoT, how it works, expand their minds, because there's going to be jobs created that nobody's even thought of now. Because somebody will get a piece of data from somewhere else, over there, and some particularly creative individual will go, hang on a minute, there's a correlation between that, which nobody's even thought of, and potentially you can create new thought streams, new ways of thinking about what they're doing. Right, I've had enough, you good?